A vector is a quantity that has both magnitude and direction. Example, walking 5 km east. The kilometer is the magnitude and the east is the direction. This is different from a scalar, which only has magnitude like mass, temperature, and time.
Scalar quantity mostly asks the question, how much, whose the vector asks how much and which way. Scalars are simpler because they just give a number like speed equal to 60 km per hour, time equal to 5 seconds, or mass equal to 3 kilograms. Vectors give more information because they add a direction like velocity equal to 60 km per hour to north and displacement equal to 5 meter east or force to 10 Newton downward.
Got it! Let's break down measurements and vectors. Conceptual overview in a simple way. Measurements. It's the process of assigning a number with a unit to describe a physical quantity. Physical quantities. 1. Fundamental or base quantities. These cannot be broken down into anything simpler. Examples include length, mass, time, temperature, electric current, luminous intensity, and amount of substance.
Alright, so number 2 is derived, which is formed by combining base quantities like velocity equals to distance divided by time, and force equals to mass times acceleration. Now, accuracy versus precision. Accuracy is how close a measurement is to the true value, while precision is how consistent repeated measurements are. And now, we have two types of errors in measurements: systematic errors and randomized errors. Systematic errors are biased or fixed errors like faulty instruments, while random errors are due to uncontrolled factors like human reaction time. And lastly, we have significant figures, which are the digits that shows the precision of the measurement.
A vector is a physical quantity that has both magnitude and direction. For example, vector quantities include displacement, velocity, acceleration, force, and momentum. Vectors are different from scalar, which has only magnitude and no direction.
Vector components. Any vector V can be broken down into components. Useful in physics problems, especially with inclined planes, projectile motion, or forces. Measurements tells us how much a quantity's plus unit is. Vectors tells us how much and in which direction.
Vector operations. Number 1. Addition. Head-to-tail method, parallelogram method, component method. Breaking into x and y parts, then adding. Number 2. Subtraction. Add the negative of a vector. Number 3. Multiplication. Dot product or scalar product results in a scalar. For example, work equals force times displacement. Cross product or vector product results in a vector. For example, torque equals R times F.
Ways to add vector. 1. One-dimension straight line. If direction are the same, just add. For example, 10 km east plus 6 km east is equal to 16 km east.
If the direction is opposite, subtract. Take bigger direction. Example, 7 kilometers east plus 12 kilometers west is equals to 5 kilometers west. For number 2, we have two-dimensional tail-to-tip method. Connect vectors head to tail, then draw the resultant. Next is parallelogram method. Draw both vectors as adjacent sides of a parallelogram, then the diagonal is the resultant. Lastly, mathematical method. Use the Pythagorean theorem and trigonometry or SOHCAHTOA to calculate the magnitude and angle. Example, 2.5 kilometers east plus 3 kilometers north resultant is equals to 3.91, 50.2 north of east.